So some satellites, like Landsat Thematic Mapper or Landsat 8, collect information from the red, green, and blue portions of the electromagnetic spectrum, in addition to other ones that are invisible to our eye, like the near infrared, the middle infrared, another middle infrared, and the thermal infrared. So this gives us a real advantage because then we can display our satellite imagery, our digital imagery, in a way that actually mimics the natural color of things. So how does that work? So once again, we have all of these different bands of satellite imagery over here. And once again, each of these different bands is associated with a different portion of the electromagnetic spectrum. For example, in this case, 4 might be associated with the red portion of the electromagnetic spectrum, 3 with the green portion, and 2 with the blue portion of the electromagnetic spectrum. If this is the case, then we can actually make a true color image using remote sensing imagery. And this is a famous example of the living Earth, which is a true color image of the entire Earth cloud-free. So the way that we do this is that we just, whatever was measured in the red portion of the electromagnetic spectrum, we display it with the color red. Whatever was measured in the green portion of the electromagnetic spectrum, we display with the color green. And whatever was measured in the blue portion of the electromagnetic spectrum, we display with the color blue. By combining red, green, and blue and making each one of these 8-bit or 1 byte of information, we have 2 to the 8th or 256 shades of red we can use, 256 shades of green, 256 shades of blue. That equals 2 to the 24th or 16 million different colors that we can actually display that will approximate what the actual colors are on the surface of the Earth. So once again, 0 would be black, 255 would indicate a pure red, 0 would be black here again, 255 would represent a pure green, and 0 would be black here, and 255 would represent a pure blue, and we can combine those into 16.777 million colors. One way of thinking about these red, green, blue combinations would be the red, green, blue color cube. So in this example here, black would be in the lower corner back here where all 3 of these are equal to 0. And white would be in this forward corner here where red, green, and blue are all equal to 255 or the maximum value of red, green, and blue. And you can see that if something only has red and no green or blue, it's going to be a pure red. If something has blue and no green or red, it's going to be a pure blue. And if something has green but no red or blue, it's going to be a pure green. Also, we can combine 2 different colors in order to get other colors. For example, if we combine red and blue, so we're up in this corner of the cube, we get a magenta color. And if we combine green and red, we would get a yellow color. And if we combine green and blue without any red at all, we would get this cyan color here. So cyan would be blue equal to 255, green equal to 255, and red equal to 0. So what we can then do is take each of the bands of the remote sensing data as they were measured, and we can see what color would be associated with them. So these would be the bands of the satellite image, and in this case here, the first pixel had a value of 255 for red, 0 for green, and 0 for blue, so it would receive a color of red. The second pixel, a value of 0 for red, 255 for green, and 0 for blue, so it would receive the value of green. The third pixel, a value of 0 for red, 0 for green, and 255 for blue, so it would be pure blue. These ones here get a little more complicated in the second row. Here we have 255 for red, 255 for green, and 0 for blue, so that would be the yellow color. And if you're unsure of what pure red and pure green put together are, you can look back here. If we combine 255 red and 255 green, we would be right up in this corner here, and that would be the yellow color. And then on the second pixel, if we have 255 red and 0 green, but 255 blue, then we would get the magenta color. And if there's no red, but a maximum value of green and blue, we would get the cyan color. And of course, if we get 255 for all 3 of the pixels, that would be white, and 0 for all 3 of the pixels would be black. So in a true color image, we can think red is being mapped to the display color red, or what's measured as red by the satellite is being mapped to the display color red. What's measured to in green by the satellite is being mapped to the display color of green. And what was measured in blue by the satellite is being mapped to the display color of blue. This is what we typically do, but we don't always do this. Sometimes, instead of mapping to 2, 3, and 4 in this example here, we come up with a false color image. And with a false color image, we're not mapping red to red and green to green and blue to blue. What we're doing instead is what we see here. So what was measured in the infrared part of the electromagnetic spectrum is being mapped to red. What was measured in the red portion of the electromagnetic spectrum is being mapped to green. And what was measured in the green portion of the electromagnetic spectrum is being mapped to blue. And in this case, what we would see is an image that looks like this, where we have very distinct colors. A lot of times the reason we make these false infrared colors is because healthy green vegetation, this is San Francisco, here's the Golden Gate Bridge here, the water, but we can see Golden Gate Park here, and areas that are healthy green vegetation just show up as a bright red color in these sorts of examples here. So this false color infrared imagery is very good for that, and it's just achieved by mapping different portions. Right now we're using the near infrared, the red and the green, but we're displaying that as red, green, and blue. And we can look at something like this if we're unsure about how to map things. This is coming from Landsat 8, and if we wanted to map something in true color, we would assign red to band 4, green to band 3, and blue to band 2. And that's what's shown over here. So if we want natural colors, red is assigned to band 4, red is assigned to band 4, green is assigned band 3, and blue is assigned band 2. But if we wanted to do color infrared, we would do a combination called 5-4-3, which would be that red would be assigned to near infrared, green would be assigned to red, and blue display would be assigned to green. So we can always look at these sorts of things and determine how we can make images such as this false color infrared image.